of, you know, when you go left to right, it's just about comparison. You might want to say that we should have used comparatives here, but let's put this aside. We actually did as well, but let's put it aside. You know, I have a separate lecture about comparatives, so we're not going to get there right now. And here's what we find. What we find is the following. When you go from left to right on these 7 kinds of proportion, you can see that as you get to the middle, this is reaction time. As you get to the middle, you can see the reaction times go up. Now, this is what you would expect, no big surprise. If the proportion here is 1, it's more difficult than if the proportion here is quarter. It's a quarter, it's like 4 out of 16. And likewise in the other direction. So this, you see this kind of pattern. But what you see that's quite interesting is that with less, you get the same kind of curve whose baseline is simply higher. And there are 2 lessons to be learned from this. First of all, that indeed you replicate the effect, in a sense, the effect that these guys got 1,000 years ago with negation. Maybe you replicate it, depending on how you view things. But moreover, there is no interaction whatsoever between the visual properties of the image that makes the sentence true or false and your reaction time. You could have imagined that there would be an interaction, that in fact the strategy that you employ when you interpret, when you make sentences with less true or false, is different from the strategy that you employ when you use more. In this case, there would be an interaction between the way you perceive quantity and the way you process negation, or, you know, abstract negation, whatever it is. But you get nothing. They're completely modularized from one another. Moreover, the sharp-eyed among you may have realized that the x-axis here, namely the axis on which I represented the numerosities that are here, is logarithmically compressed. And this is exactly Weber's law. Once you compress the x-axis logarithmically, you get a curve that looks quite symmetrical. There are fancy statistics to measure it, but you know, ask me about it, I'll be happy to answer. But the bottom line is, from a numerosity, numerical or quantity perception kind of perspective, this kind of, the subjects here are very, very well behaved. They behave exactly in keeping with Weber's law. And when you give them sentences with less, they simply give you the same behavior, except it takes them longer. And here's the coolest part. When you do this with like a greater than or lesser than, they don't translate it into linguistic objects. Unlike what your initial drive would say, of course, you know, they see these things. These are very weird expressions. It's quasi-algebraic something. They translate it into sentences. Well, if they did, they would give you the same kind of thing. It would even be even longer. But no, you can see that both curves are just sitting on one on top of the other very, very nicely. And you can see that the effect that you get, whatever it is for now, has nothing to do with your perception of these kinds of objects. You analyze them exactly as they are. And one thing that you can object to is that maybe the design, given that here the presentation was visual, maybe there was something about the design of it. Sometimes people jump at this stage of the talk and they say, well, you read this one from left to right, maybe you read this one from right to left, because the sentences unfolded in time and these objects did not unfold in time. So no wonder that you get this kind of thing. We actually didn't think about it initially, but then we ran these experiments where these things unfold in time. Where am I? These things unfold in time. First you see the left part, then this thing is added, then the last thing is added, and there's no way for you to go back, because this is how we set it up in terms of the time course, and still we get exactly the same results. So this would not be an objection. It's a common objection here. One thing I want to point out to you is that in fact this negation effect, whatever it is really robust. And you can see here, I think there are 21 subjects here. And I think even if you look at the individual level, you can see that almost all of them have this effect on the individual level. And we've replicated it since 5,000 times. It's really an amazingly robust effect. So here's what we want. What we want is to get what we really are interested is the effect of this, but the effect of this minus whatever effect it is that we would have gotten from non-linguistic stimuli that in fact have the same matching properties. I'm getting around the need to say meaning, okay? So the task is exactly the same, the contrast is exactly the same kind of contrast, but it's a non-linguistic task. And what we want is to get this effect, but kind of control for it by whatever effect we would get between these two guys. And there's a name for it in experimental design. It's called an interaction effect. What we want is a negation, if you will, by instruction type, linguistic versus symbolic interaction. So statistically speaking, we get exactly that. This is denoted by this little star here, namely the effect of the quantifiers is greater when we collapse across all of these proportions, and we get one bar that represents all these, the performances, the reaction times of the whole group of all this proportion. It's a huge amount of data, just so I tell you. When we collapse across them, we get a significant difference between less and more. But moreover, when we compare when we calculate the difference of differences, this is the interaction effect, we get a highly significant effect, namely the difference between the differences is big. And in this direction. And that's what we want. Why am I telling you all this? Because now we took this experiment and we put it in the magnet. We did exactly the same experiment. For technical reasons, we actually used a smaller number of proportions. So here you have 7 in the reaction time experiment. And in the fMRI experiment, we had only 5 because there's a limit on how you can have these poor subjects sit in the magnet. There, you know, in the reaction time study, there were 1,200 items, 1,200, and participants came back to the lab 4 times. Some of them dropped out in the middle, even though they got the money only at the end. 50 Canadian dollars, it's not much, okay? Here we had just 1 session, so we had to cut down on items. We cut down a little bit, but we got exactly the same effect. So here you can see the pattern that we get in the reaction time. And what we did now is we asked a very, very focused question. What is the brain area or brain areas such that when we look for an interaction effect exactly like we looked here, what brain areas would be activated? It's a highly, highly focused question. And you can see that there was a single brain area. You have to work very hard for this, okay? It's like sometimes, you know, you spend half a year, the linguists among you, you know that sometimes you spend half a year to get exactly the kind of contrast that you were looking for. But this is what we did here. This is the effect that we're looking for. Exactly this effect. And there was one brain area, which is this blob that you can see here. It's not very big, but you can see it. And it has 2 interesting properties. First of all, it gives us what we have. Secondly, it's not in the typical language areas. It's somewhere else. It's not in the typical language areas. But before we go and study what exactly it is from a neurological perspective, I want you to notice something else. These results, in fact, are not, notice that here we have a difference, like overall, we have a difference between the less than and more than. But in this graph, we have nothing. So I cheated you in a sense. And the reason I cheated you is because I wanted to give you the actual results from the behavior of the subjects when they were inside the magnet. So these results are results that we obtained at the lab where the subjects came back 4 times. And you can see that these curves are sitting right on top of the other. Here, these are the results that the subjects gave us when they were pushing the same button, the same task, but they were lying inside the magnet. Much noise, all kinds of problems, they're uncomfortable, whatever, they gave you the same results. And what I wanted is to do this in order to compare their reaction times to the net, what we call the net negation effect, namely the magnitude of the interaction effect in fMRI. So first of all, impressionistically, you see that they're the same. I hope everybody can see that it's exactly the same kind of thing. But this was not enough for us. What we asked ourselves is this: suppose that there are individual differences here. And in fact, we could see in the previous slide, we could see that there are individual differences. So for some speakers, the cost of negation, which is this, does everybody see the difference between the red column and the blue column? This is the cost for your abstract negation. So for some speakers, the cost of your negation is high, and for some speakers, the cost of your negation is nothing. So let's call these guys fast negators, namely they pay a very small price for negation, and let's call these guys slow negators. It's expensive for them. One thing that you would imagine, if these results are for real, you would imagine for there to be a systematic relationship between your being a slow negator and the fMRI effect, and your being a fast negator and your fMRI effect. I don't know ahead of time if you're a slow negator, it's because your signal was very slow, or you're a slow negator because your signal was more intense. But you expect a systematic relationship between the two. So what you do is you correlate the effects between the two groups. So here we have all our subjects. So each of these dots represents a single subject. And here you can see it's a single subject. Never mind the specific numbers, because it's some kind of a relation. Sorry, it's some kind of a relation. But what you can see, it's going from fast to slow, namely a small interaction effect for these subjects and a big interaction effect. These are the fast negators and the slow negators. And then this is the intensity of the brain signal for each of these guys. And you get a nice correlation between these two. So that means that if you're actually a slow negator, you work hard. So, you can think about it as if we now have a clear hypothesis about the processing cost of negation and its relationship in the brain. But let's leave this hypothesis aside. I'm just giving you arguments to believe that this area that we obtained is for real. You need this. There are too many articles out there. They claim that they discovered a new area in the brain, but they don't support it from 5,000 different directions. Maybe it's just a fluke of your specific experiment. So we tried to look for as much support as we could in our results to convince ourselves that this is for real. Okay, so this is one kind of thing. And again, we're just looking at it from a functional perspective. Namely here, we're looking at the behavior, we're looking at the signal intensity as the subjects were thinking about these things while they were verifying the images for us, and we're looking at the correlation. We also have results about what they did with Weber's law. I don't want to talk about them, but please ask me, I'll tell you about them. But they're actually kind of nice. The next thing we did is we wanted to be convinced that this has anatomical reality behind it. So one thing that some of you may have heard is that there was this guy named Corbinian Brodmann who was at the University of Düsseldorf and never got a job. Okay, so he had his habilitation in Düsseldorf, and then he went to Berlin. And apparently, when he got to Berlin, there was somebody who hated his doctoral supervisor, Oscar Vogt, and that's why Brodmann never got a real professorship anywhere. That's life. But still, who remembers his Berlin professor? Everybody remembers now Brodmann, but then Brodmann, when he was alive, he was kind of miserable. So his project in life was to look at slices of brains. There were all kinds of staining methods that had been invented at the end of the 19th century, most notably by Ramon y Cajal from Santiago Ramon y Cajal from Spain, and by Camillo Golgi in Italy. And the idea was that you can actually look at cortex and see something, because cortical brain tissue is very dense. So you need some way to get contrast. So these selective staining methods gave you these contrasts, and you start seeing that there are layers here. So if you look carefully, those of you who have never seen such things, you can see that there's actually a nice flow here. You take this nice flow, you study it more seriously and carefully, and you identify layers. And the interesting thing about it, not only do you see layers, but you see different patterns of layers in different places of the brain. And the most remarkable thing about it is that the changes from one pattern to another is not gradual, it's abrupt. This is amazing. And what Brodmann hypothesized, roughly put in today's terms, he had a modular hypothesis. And the claim was that the brain is a modular object. And you can see this is very famous, this kind of a caricature of Brodmann's brain. If you want to know how it came about to be such a caricature, I can tell you about it later. But that was the hypothesis. And this hypothesis was revived mostly by Carl Zilles and Katrin Amund. One second. By Carl Zilles and Katrin Amund from Jülich. You may have heard about them. Carl was a dear, dear, dear friend of mine for 20 years, and he passed away 2 months ago, not from Corona, even though it was already during Corona. And Katrin is my closest collaborator in the world for many, many years. And they revived it and they turned it into a field that is called computational neuroanatomy. So all these things are doing computationally, and the people who study anatomy these days are physicists. And here what you can see, I'm not going to talk about it, but what you can see here is a true or much truer representation of the two pieces that constitute Broca's area, namely Brodmann areas 44 and 45. You can see them here represented in color because they're probabilistic, and it's a long story that I will not tell you much about right now. So these are the typical brain areas that are activated in linguistic tasks. And one thing that we could see is that the area that we were actually looking at was outside the typical language areas. Now, that's another reason to suspect that this is not a real effect. We have something that has to do with language, and we get something that's not where it's supposed to be. So in order to be convinced that it is real, we wanted to see if this area, in fact, is supported by a coherent piece of tissue. Namely, if the claim is that these microscopically discovered modules, in fact, support distinct functions. So this was Brodmann's claim, that the reason you want to parcellate the brain into these pieces is because these histological patterns are an index of local connectivity, and local connectivity is the index of separate functions. So you want to think that these kinds of anatomical pieces, in fact, support functional pieces. One thing that you want to convince yourself is that you're looking at a function that lives in an area that constitutes itself an anatomical piece. It could, in principle, encompass 3 different areas anatomically, in which case you would know that whatever you discovered is not constituting an anatomically coherent piece. But if you do discover that it comes out of an anatomically coherent piece, you learn something new. And it strengthens your belief that you're onto something that is biologically viable. So this was actually a case, it's the first case to my knowledge, where the function, namely whatever we discovered in this experiment, pointed to the anatomist. So we actually told the anatomist, okay, go and find the nature of this specific area. And they did. And you can see it here. And this is an area that's now called ID7, insular disc granular area number 7. Forget about the details of it. And the next thing to do was to try to look for the degree of match between these 2 areas. Okay, so we want to see if this area and this area overlap nicely. And you can see the picture here. So this is the picture that you see, and it's quantifiable. And there are 2 things about it which you can actually see nicely. First of all, this is a functional cluster. This is the anatomical cluster. And what's important is that they actually exclude Broca's area. There's no overlap. And I can tell you my my speculation about what this area is. So interestingly, when you think about what happens when you make this, when you reason and you make decisions, you take linguistic objects. That's how things work in life. You take linguistic objects, you put them one next to the other, and you try to reason over these linguistic objects. But it's likely that before you reason over them, you convert them into some logically coherent pieces. And it so happens that the area of the brain in which you do make these kinds of reasonings is in the anterior cingulate, which is in front of this thing. So the idea is that you first construct linguistic representations, convert them into some logical objects. If you want to think about LFs, think about LFs, and then you ship them to decision-making areas. So this is a story. It's not yet a real hypothesis, but it's actually a pretty good story. And if you want to be dramatic, you can say, okay, well, maybe this is where language stops and logic begins. And I'm not going to make much of it, but please argue with me if you like. I like to argue. So here I just want to show you a 3D representation of this, just because you can actually see that there really is no overlap. It's too long, but I'm going to stop it here. You can see that there's really you can see two things here. One, there's no overlap between these two clusters and the language areas. And two, if you look at this little dot in the middle, this is the center of gravity of each of these, center of mass, actually. You can see that they basically sit on top of one another. So the sizes of these guys are not the same, and it's just a function of thresholding. And I'm not going to talk about it now, but the idea is we're really seeing an area that's not just functionally coherent, but also anatomical. Okay, so this is the end of this story, and I'm just going to show you one thing to show you that you get the same effect with patients. So this is a patient, a Spanish-speaking patient. It's actually the first patient I ever tested on this kind of thing. It's a patient in Buenos Aires, and let's see what you get.
Muchos de los círculos son celestes. Sí.
So this is, many of the circles are blue in Spanish, and you could see how quickly she responded.
Muchos de los círculos son celestes.
This is somebody
Sí.
who's affected both in Broca's aphasia, in Broca's area and elsewhere. This is few.
Pocos de los círculos son azules.
¿Más?
She's asking for more.
Pocos de los círculos son azules.
¿Más?
Pocos de los círculos son azules.
Poquitos.
I was actually quite shocked when I first saw this. This patient actually has a lesion
Pocos
that
de los
encompasses.
círculos
Okay.
son azules.
This patient had I'm not going to make much of it, but it's just a nice way to see. This patient was actually affected this is the left, it's radiological, so it seems on the right, but the patient was affected both in Broca's area and much beyond that, encompassing the part that we're talking about. I have another one from Hebrew. You can see the same kind of effect.
בתמונה יש יותר ריבועים צהובים מריבועים כחולים. בתמונה יש פחות ריבועים כחולים מריבועים צהובים.
נראה אותו דבר.
So it's a little bit of an exaggerated effect, and there are a lot to be told about it, but at least you can also see the app that we've developed for testing. This is a big project we have in a Jerusalem hospital for testing and in fact potentially treating patients in the acute stage. It's actually a pretty interesting app, but I'm not going to talk much about that. Anyway, so what have we done so far? We looked a little bit about the cognitive cost of some hidden negation, and we looked a little bit about its neural cost. But of course, what we haven't done is we actually haven't really given you a price list of negation. And the question is, can we provide a price list? Namely, do overt negations cost like covert negations? What happens when you have more than one negation? What happens when you have a negation in hidden in the meaning, in presupposition? There are tons of questions that can be asked here. Once you open this to discussion, all it takes is for you to know a little bit of semantics, and you can just like start expanding this kind of question and translating it into a processing theory with, you know, first of all, starting with just a price list of negation. And this is something that we did to some extent. And one thing, you know, and this is what got us started, is that two negations are supposedly giving you the same truth conditions as no negation. So, you know, it shifts from odd to even, from even to odd, and so on and so forth. So the question is, do the costs of negation accumulate, or maybe negation pairs cancel each other? And for those of you who have taken 5 minutes of linguistics, no, it's actually at the issue of monotonicity. Okay, and the question is, what governs our perception or a sentence processing in the case of negations? Is our perception governed by just some cumulative calculation of this type, or is it rather governed by the monotonicity of the object that we're dealing with? And this is one question that we asked with Andreas, Haida, and again, believe me, I'm not doing justice to any of it because I'm not giving you the real theoretical reasoning behind it, but I just want to dwell on the specific experimental results, and then we can debate a little bit because I want to get to the end of it. It's getting to be a little long here, even though we started late, not my fault. Okay, so here's one experiment we ran. We did the same kind of experiment, except we added a negation. Notice that the negation was added not as a, well, I don't know, but at least there's a possibility that the negation that you see here is not sentential. It may very well be that it's just something that's part of the generalized quantifier here. But maybe it is sentential. So, of course, we have two theories here right now before we talk about linguistic things. We have two theories. One theory that says, well, the cumulative cost of negation is very simple. If negation has some kind of a cost, you know, just take the number of negations that you have and that's it. And that would mean that regardless of whether the negation you have is overt or covert, you would pay the same price. This is like a very uniform price list. So moving from more to not more costs you one negation, moving from more to less costs you one negation, and moving from more to not less costs you two negations. And this is what you see here. And remember, it's always collapsing across truth value, something that needs to be taken into account maybe later. But we have another cost that, again, I presented it to non-linguists, so I did everything I could to not use the word monotonicity. So I called it cancellation negation cost. And the idea here is that you basically look at whether you have an odd or even number of negations. If you have an odd number, you pay a price, namely here and here. If you have an even number, you pay nothing. This would be the idea. These are the really stark predictions. It's not likely that you will find anything like that in the real world, but it's worth exploring. So you can think about it. Again, I was maybe a little bit too lazy and didn't change the headers here, but you can think about it as a monotonicity hypothesis. And the monotonicity hypothesis is very simple. You know, if your sentence, or you're a generalized quantifier, depending on your tastes in life, if your environment is upward monotone, namely more or not less, you pay nothing. You know, if your environment is downward monotone, you pay a price. Okay, here it's just going by the number of negations, and here it's going by monotonicity. So these are clear hypotheses to be entertained, and let's see what we got. So we tested 25 subjects. This is just reaction time. This is Ian Tan's, part of Ian Tan's experiments, but this is work that's been done jointly mostly with Andreas, and who many of you know, and with Asaf Brown, another student in my lab. And what you see here is that when you add a negation, it's kind of costly. You pay a price. So this is reaction time. I forgot to mention it. It's kind of costly. When you have less, you pay a price, but very counterintuitively, it's actually cheaper for you to move from more to less, than to move from more to not more. That's very curious. It's as counterintuitive as it ever comes. I mean, one thing you think about is in order for you to get from less into a negation, you have to decompose it. And this decomposition should slow you down rather than speed you up relative to more. Okay? But this is the result as it is, and the difference here is pretty big. I don't remember if it's significant or not, but it doesn't matter. This is not what you expect. And now the question is what you would get, the interesting question when you have not less. And this is what you get. Not wonderful, but think about it in the following way. If you compare not more to not less, which is the right comparison, you get a big difference. It's actually significant. I don't know why there's no star here, but it's actually significant. The difference between less and not less is non-existent, but the difference between not more and not less is big. So now the question is, okay, does everybody see this? It's easy to see. It's not as impressive as you would have liked it to be, but still I want you to be impressed by the fact that it's not what the standard hypothesis would expect, namely that not less would be the most expensive. This is not what you find. So now, of course, we need to account for why we did not get this. We can see, I mean, we have something that tells us, well, the reason you did not get the cumulative hypothesis to be confirmed is because, in fact, there's something about there being two negations here that plays a role in speeding you up. But why the hell did we not get what we wanted? And there's several ways to account for this. And I'm just going to mention in passing the two ways that are most evident. The easiest way to account for this, but you have to prove it, and we haven't, is to say, look, previously you were blaming these old guys for studying negation and not controlling it because negation has an extra word. Well, these two conditions have an extra negation. So even though when you run these experiments, namely you run it like this, you first show the sentence, you play the sentence, and only at the end of the sentence you show them an image, only then you show the image, and you start measuring reaction times from the time you presented the image. So it's as if the sentence is gone, still you may be getting an effect of there being an extra word. So in fact, the reason these two conditions, not more and not less, are both elevated is because it's an experimental artifact of there being an extra word. Be smart, control for that. And if you're smart enough and you control for that, you're going to get this kind of graph. This is one possibility. But there's a second possibility that, in fact, Andreas would like to explore more than me. And the second possibility is that, in fact, there's some kind of a pragmatic extra that you get here. And the reason you get this pragmatic cost comes from the fact that the behavior of these negated modified numerals is not exactly the same as non-negated ones. So there's this, I don't think I have it here, but there's this paper by Rick Nowen from about 12 years ago that presumably has some kinds of, it's something that looks like violations of scalar implicature in these cases. So like, and again, Andreas would like to argue that there's an ignorance implication that's hidden here, but let me finish and then we can get to that if you'd like. I just want to point out that there's something important here experimentally that needs to be controlled for. One thing that somebody might tell you, well, look, the reason this not less is so cheap for you, it's because it's more frequent. So there's actually a frequency effect here, because everybody knows that more is more frequent in language than less. But maybe not less is equally frequent. It so happens that somebody actually measured it. Some medical guy somewhere measured it, and it's exceedingly rare. So sentences with double negations are exceedingly rare in language. A second thing that's maybe more interesting, and this is what subjects report, subjects say that when they come out of this experiment, we debrief them, they say, well, yeah, there was this condition, not less, but we very quickly learned that we should make life simpler and convert not less into more. That would make our life simpler. This is what subjects report. Okay, well, first of all, maybe they do it, but this thing should cost them time, this conversion. And secondly, let's see if they really know what they're saying, because everybody knows that we should not believe what subjects say they did. They just think that they did so. Because if this is indeed true, it carries a very clear prediction. What they tell you is that we very quickly learned. So if we look at the course of their responses during the experiment, the prediction is that their performance during the experiment would get faster on this particular condition relative to the others. So that means that if we plot the course of their responses into this, and we set up a regression line on it, we would get a regression line for this condition, which is like the time course of their behavior. The regression line would be downward pointing, namely they would be faster, but on this condition, it would be faster than elsewhere because the learning we're talking about is only about this not less condition. So we did it. And this is what we got. Everybody gets, so we plotted each of the conditions by the order of each trial in the course of the experiment. So we had like 32 trials, and this is for each of the subjects. This is the first trial, the second trial, and so on. We divided it, we collapsed across all subjects and divided it to the different conditions. And for each condition, we set up, we calculated the regression line. And everybody gets a little faster during the experiment. That's not surprising. You get the hang of things, you become a little faster. First of all, not by much, but secondly, notice that the slope of the curve that represents this particular condition, which is the green slope, is exactly like the others. So it's an important lesson, I think, that makes these kinds of dismissive comments about the value of these experiments. Oh, sure, you learned something. You should always try to translate these kinds of comments that people give you into a testable hypothesis and then let's see if it's true. Here it's patently false, okay? A second point that's actually interesting here is you want to see, when we test these kinds of things, and I really put an emphasis on the experimental issues here because these are things that are less frequently touched upon among theoretical linguists, in as much as they love to talk about theory, and I love to talk about theory too. But this is an experimental presentation, so I want to just point out to you that when we measure here, we measure in two domains, the error domain and the time domain. The results that I presented to you were results in the time domain. And here we look at how many errors these subjects made. And you can see here, first of all, they made few errors. So overall, the lowest condition had like 83 or 84% correct. But secondly, the major factor in inducing error was the physical presence of negation. It had nothing to do with monotonicity. And keep in mind that the reaction times are calculated not over all the trials, but only over the trials in which the subjects performed correctly. And there, all of a sudden, you see this amazing effect where the time course that you obtained is not what the standard hypothesis would predict. So what have we learned? Well, first of all, you see that the neural system that supports language is modular, because not only did you find something about this abstract negation, which might have to do with your logical thinking, that's outside of your standard language domain, but you can also see how it actually behaves in the details of the time course of it, and see that monotonicity, in fact, which is lies exactly at the boundary between linguistic principles and logical principles, is in fact a major factor in language processing. And I think this is the end. Oh, not the end, because I promised you something about operating rooms. Okay, so here's what you do. You know, they're awake. So let's take a little intro about linguistics in the operating room. So here's the goal. What you want is to remove a tumor from the patient. The patient has a tumor. This is an ugly tumor. It's called glioma. It's not nice. I don't propose anyone to have it, okay? And the idea is to remove this thing by leaving the largest margin that you can have for safety in case you left something out, but having the smallest, the minimal amount of functional damage. And for that, you use the patient, if it's in an area that has a major function such as language, like this patient, you want to use the patient in order to help you navigate into the tumor. Now, you may know that the brain does not have sensory innervation, namely, the brain doesn't feel the brain. You know that. And if that is what you know, then you can actually wake up the patients in the middle of an experiment. And if you do so, they're not going to be in pain. So the idea is to wake up patients after you had opened their skull and after you had started this operation, and then you test the patients before you touch their tissue. You test the patients by introducing an electrode, like the one that you see here, that blocks the activation. I'm sure that you've seen such things on television with people during an operation playing the violin or something like this. Here we test them for language. And we test them, among other things, we test them on sentences that have upward and downward entailing quantifiers. So the thing is this, these are the surgeons. So this is Marion Rapp, the surgeon, and she's sitting here looking at it from the perspective of the brain. She's looking at the brain. I am standing here on the other side of the face of the subject, of the patient, and with a student, we're testing using this as a similar app to the one that you've seen before, using an iPad here. She will stimulate upon being instructed to do so. She is the surgeon. Again, we agreed upon the positions where stimulation would take place. And the idea would be, we test the patient before stimulation, namely a day before the operation. And then we come into the operating room and we test it during it. And if indeed the patient's performance would drop, we know this is not an area to be touched. Because again, these patients, their life expectancy, even with the operation, is not that long. So the top priority for these surgeons is the quality of life. You don't want to take language away from them. You take language away, it's like dropping the quality of life close to zero. And in many instances, they just don't do it. So this is the thing. And we have this app. We test here. You can see an item that tests words. But in a second, I will show you how this works. Okay, so here you can see it from the perspective of the brain, this movie. This is the perspective of the surgeon. I'm standing right behind her shoulder with a camera. This is the perspective of the patient. The patient's open brain is separated with a sterile field by a clear sheet, like a plastic sheet, which is what you see here. And what you can see here is the iPad that is sitting here, and Andreas Haida will be operating it, and he is going to start it at a given point, and he will give the surgeon an instruction to actually stimulate at exactly the same time that he is starting the stimulus. And here's how it works. So you can see the screens at the top.
Jetzt auf dem Bild sind weniger rote als blaue Punkte.
So you heard him say yes, and this is where she started started stimulating, and this was the item. There's another one. See, here she's stimulating.
Auf dem Bild sind weniger gelbe als blaue Quadrate.
So she's stimulating, he's playing it, and we want to look for the performance of the patient. I will show you now another move of, sorry.
Jetzt. Der Papierkorb enthält den Karton. Der Papierkorb.
Shut up. I want to show it to you from the perspective of the brain now. So you will see different items. This is a syntax test, like a movement, a syntactic movement test. You know, you're just going to get simple sentences here. But here you can see there are like 3 stimulation points, and they're going to be stimulated one after the other. And this is how we're going to get a fairly precise evaluation of the patient's abilities while this is being stimulated here.
Jetzt. Der Papierkorb enthält den Karton. Das ist jetzt richtig. Jetzt. Der Bauarbeiter schubst die Frau.
So you can actually see that this might have some value in life, this kind of linguistics. Hopefully we're not wasting our time. Again, there are many issues. Just to show you, this is the same patient who you saw early on, the patient, this patient. You can see her a couple of days later. I'm testing her here.
Auf dem Bild sind weniger rote als blaue Punkte.
So this patient was actually back to work about a month later. This is amazing, I think. You know, I mean, not that I contributed anything to her well-being. I would be the last to say that. But, you know, these things help. And if we can give these neurosurgeons a little bit of better precision to tell them, don't cut from here, but cut from there, I think it's an accomplishment that few linguists can be proud of. But I'm not there yet. All right. I would just conclude by saying this thing needs money. There are many organizations contribute to it. There are also many people who play the role here in many countries, and that's it. I'm done. That's it.
Okay, so we can't really, you know, clap, unfortunately, but there is a clap reaction. So it was really, really, really interesting. Thanks so much for this, Joseph. It was, you know, the finale for me was shocking. So did you have some time for discussion and some
Sure.
questions? So
Yeah.
you're not, okay, great.
Yeah. There's going to be a fish dinner later, but you're not invited.
Unfortunately. Okay, so
let me just turn on the light here so you can see me better. 1 second.
Yes.
Yeah, go ahead.
Questions. I have a few questions, but I would like to give priority to other people. So if anyone has a question, raise your hand, make some noise, or just start talking. I think one guy. Yeah.
Okay, whatever.
Well, it is really my turn. Thanks a lot. This is really interesting. I have several questions, but I was just wondering about when you make the distinction between linguistic versus non-linguistic negation, where you discuss the sentences versus the symbols. And I'm wondering how much of language is actually not behind those symbols. If you have the smaller than or bigger than, to what extent aren't we really using some language in disguise where the symbol really reflects linguistic negation as well?
Yeah, it's a good question. And I mean, the only answer that one can give is that the proof is in the pudding, in the sense that had there been, I mean, here's, let me just be less polite than you, because it's work that I'm personally involved in, and say that it's not at all clear how one can talk. I'm going back to, so this is what you have in mind. And I should say, 1 second. Yeah, okay. It's not at all clear how one talks about the representation of these things in the absence of language. So what am I talking about? Okay, you know, again, I'm being harsher because I'm not as polite as Hede, not as polite to myself as Hede. But you see, the thing is, the proof really is in the pudding, because had had this been translated into a linguistic object, we would have expected the effect to manifest just as it did here. And so I think the easiest way out of your question is to say the following. Look, it's not as if I have a very intelligent account of what is going on when we get these reaction time functions. But I do know that the critical property from my perspective, which is this elevation between, you know, the less and the more, the critical property is not visible here. And let me put it in a way that's a little bit that's a little clearer. So if you have to translate, I'm sure that's what you had in mind, Hede, if you have to translate these quasi-algebraic symbols, symbolic representations into sentences, you would use a comparative. This is the most natural way to do it. And we actually tested comparatives. The reason I'm not presenting them here, so if you go to the paper in Cognition, you will find comparatives there. And there's several, and there it's actually presented as an experimental reason to do this. And let me tell you what we did. So first of all, if you look at comparatives, we used phrasal comparatives. So, you know, there's an existential, so there are more blue circles than yellow circles. There are fewer blue circles than yellow circles, and so on and so forth. This is what we used. So here you have the exact analog of what you see in these kinds of expressions. So the argument here would go in the following way. I don't know what representations you have here, but if I set up the closest relative of these weird objects, the closest linguistic relative, it would be comparative sentences. And you get the same effect for comparatives as you get for these proportional quantifiers. You get exactly the same effect. And you do not get this effect for these weird objects. So at least one thing I can exclude is that it's not as if every representation that you put in your head gives you the same kind of effect, like some kind of a negation effect. So the reason I'm saying it is not to disagree with you, but rather to say, well, okay, I agree with you completely. It's hopeless to understand how to represent these kinds of cooked up expressions. But the one thing we know about them is that they're not processed, they're not giving you the same kind of processing signature that you would have expected had they been translated into language. Because if they had been translated into language, you would get this effect, and you don't.
I fully agree with that. Though I have one follow-up question, if I may, because there's quite a bit of discussion in the semantics of things like less than, except, few, including a whole bunch of negative indefinites, whether you should think of them as having one single semantic representation or whether they're composites of a negation plus something else.
Sure.
And you might even wonder whether there's cross-linguistic variation to it. So maybe it's even possible to understand these experiments in such, or the outcomes of these experiments in such a way that you say this might be even neurolinguistics evidence for English less than to really be a composite of a negation and something else, because otherwise it should have the same reaction times as a plain comparative. And maybe we can even see in other languages where expressions like less than act differently.
Well, I have to tell you something, and I think this is the first time I read your work. So the first time I encountered this was about 8 or 9 years ago in Buenos Aires when I tested this patient. This was the first time that I realized there was something there. And the first experiment that we did in fMRI with this was too crude. We did it in Jülich, actually, with Stefan Heim. So there's actually a paper. Stefan Heim is the first author. It's a paper in Frontiers. And it was too crude, so it gave us a big area that included most of Broca's area. What I thought, and this is based mostly on work by yourself and by Doris Penka, I initially thought that what we're seeing is some kind of Aleph movement of a negative element. This was my initial thought to say, okay, this is terrific because, you know, I've been championing this idea that syntactic movement is happening in Broca's area. And I can tell you that I always asked myself, would we get the signature, the signature of abstract movement? And the first, I tried it over 20 years ago. I tried to test it with a phasics and failed, and I did it in a stupid way then, but I tried it with multiple questions, and it was a colossal failure, and I never came back to this. You know, I had other fish to grind in life. So this is a question that I asked myself many times, and then I said, oh, maybe what we're seeing here is some kind of an index of syntactic movement of the abstract type. Beautiful. All kinds of problems with that, but this is what brought me actually to your work and the work of Doris Penka. Exactly that, the thought that you might actually see something that you would be better off looking for in other languages, like, of course, German and Dutch, right? That's very clear. To my knowledge, and I think I have some knowledge on this, nobody has actually asked this kind of question from a processing perspective. I haven't seen anything. There's one paper or two papers on negation and aphasia, you know, by Judith Rispens from many years ago, but these papers don't really touch on this kind of issues. So I personally am not aware of any literature that's cross-linguistic in this respect. But of course, I completely agree that, in fact, the first times I presented it, I presented the famous, you know, I would present, you say, du must keine Krawatte anziehen, and things like that. This was like my first examples. I was very excited about my big discoveries in this world. Of course, I went there, but I never went there experimentally. And maybe somebody in the audience would like to, you know, maybe they're students, postdocs, more senior people who would like to do this. I would love to do this in German. You know, we have the know-how. I even speak a little bit of German. I come to Germany a lot. You know, I mean, there are all kinds of opportunities here. You don't have to go to Jerusalem for that. You know. Anyway, so, you know, I can't disagree with you. This is my only point. I would love to disagree with you, but I can't.
We'll find some other topics to disagree.
Yeah, I mean, just have to get familiar with Hadi a little bit, and then you will start disagreeing with him much more often.
Okay.
I'm kidding. Any other question before I shoot mine? So
nobody wants to disagree with me. Come on.
So I'm gonna try. No, I'm kidding. I don't want to disagree with you, but I'm gonna try to challenge you a little bit, at least to have some fun. No, I'm kidding. So no. So the first question was kind of specific to the methodology, and that's actually something that I really want to ask you also to help me understanding this paper. So why? So if I got it right, basically the functional localizer was driven not by the effect of negation itself, but by the comparison between a negation in the linguistic condition and the negation in the non-linguistic condition, right? What you call the net negation effect, right?
Yes, this is an interaction effect.
Exactly.
Yes.
So I wanted to ask you why do you need this interaction? So why do you need that basically there is no difference in the two non-linguistic conditions, and then there is the difference of negation in the linguistic?
Well, because, you know, the thing is, I mean, this is a question of what's the best control in life.
Yeah.
You know, I mean, there's never a best control, but what you want is to have a good control. And you kind of, if all you do is you compare a sentence with more and a sentence with less, you have all kinds of these psychological factors, potential psychological factors like word frequency, okay? That's one potential psychological factor. Or you have this business of reading something from left to right versus right to left. Like, you know, you get presented with a sentence from left to right, but then the question is the larger quantity the one that you see first or you see second? Things of that type. These are like psychological factors that you want to get rid of. Now, experience has taught me that if you do not control for these things that seem stupid from a theoretical point of view, you get noise. Now, for those of you who've ever ran a psychological experiment, which has quantitative aspects to it, you know that your biggest enemy in life is noise. And what you want is to reduce noise. And it so happens that when you control for such things, I'm not giving you a principled answer. I'm giving you an answer by an experienced geezer, okay? That's the answer that I'm giving you. Just experience has taught us that if you control for these stupid things, it's better for you, okay? I'll give you, my best teacher is somebody you see on this slide, okay? So this is Galit Agmon, who's just graduated from my lab. This is Isabelle Deschamps, who was a postdoc and now teaching at a college in Ontario. And this is Jonathan Levenstein, whose grandfather actually has a doctoral degree from the University of Göttingen. Yes, I actually saw it once. His name was Löwenstein, or Löwen, yeah, something like this. So Jonathan is a physicist. He's my closest collaborator in Jerusalem. And he's like a neural networks kind of guy, but he's also a very careful experimentalist. And he taught me so many things about controlling for all kinds of stupid learning effects. He taught me really amazing things of how to be a careful experimentalist in a way that nobody in linguistics teaches you that, because it's supposedly not sufficiently important. And you can think about this kind of thing as a control in this respect.
Yes, so thanks. So can I just make my question a little bit more specific? So, for instance, why wouldn't you look for an area that is actually sensitive to both comparison? So, you know, if we assume that you actually might involve some sort of abstract negation process, also when you compare like greater than compared to minor than.
Because you get half the brain.
Right.
This is the answer. You get half the brain, really. It's like all over. But let me tell you something about comparatives, actually. So comparatives is an interesting case in two respects. This is like a snippets of another talk. So if you go to this cognition paper, you will see that the comparatives are presented there as if they're supposed to be a control. Control for what? One possibility is that the effect that we got here for the lack of an effect that we got in these things is because you do not have to listen all the way to the end of this, to look all the way to the end of this expression that's displayed to you in order to know what the question is. It's sufficient for you, since you know that there are only two colors, and we're telling you this in advance. Once you get to the inequality symbol, that's enough for you. So if this thing unfolds over time, by the time you get to this point, you know what you need to do. And you have perhaps enough time to prepare before you answer. So you're beating the clock, and subjects always try to beat the clock because they're lazy, and for good reason. So you're beating the clock, and the reason we're not finding anything here is because all our subjects were so smart that they beat the clock. In this case, they always have to wait to the last word, because only there do they know what the task is, because it can be either blue or yellow. Okay? So you can think about it like that. So we thought, well, maybe this is the case. We looked at comparatives. And comparatives, in the middle of the sentence, once you finish the matrix clause, you don't even have to get to the comparative clause. So if the sentences are, there are more blue circles than, it's not a clause, these are phrasal, but there are more blue circles than yellow circles. You don't even need the second half of the sentence. You can stop. You can stop attending, prepare an answer, and of course, the expectation is that with comparatives, you're going to get the same thing as you got with these inequality symbols. But you don't. You get exactly the same kind of curve. Now, here's why it's a problem. It's a problem not only because it's not what you expect. So first of all, the good news here is that you get this to be a linguistic effect that carries over even if you change the sentence type. We actually tested it not just with these less than half and more than half, we tested it also with degree quantifiers, namely many and few. So it generalizes very nicely to degree quantifiers. I have to tell you that this experimental paradigm for me has a history because I was very much inspired by a dear friend of mine named Martin Huckel, who some of you may know. I was very much inspired by him. You know, he'd had this experiment on most versus more than half about a little bit over a decade ago. And I didn't think, in as much as I think he's wonderful, I thought I could do better. Okay, I was probably wrong in that case, but doesn't matter. It took me into this monotonicity world in a kind of an unexpected way. But here's the problem. Notice that what you got in comparatives is the same kind of difference between more and less. But now stop for a second and think about what we did in the case of these double negations. What I told you is that the reason we got these effects is due to monotonicity, right? But wait a minute. Comparatives have mixed monotonicity. One part of them is upward monotone and the other one is downward monotone. So what I hope is that all of you know about Irena Haim's paper Little and Hotzer Ruhlmann's dissertation and a lot of other stuff on comparatives that tells you that if you want to use the overall monotonicity of the stimulus sentence, the prediction is that the difference between more or less in terms of reaction time would be 0.
Yeah.
Right, because one of them, a sentence with more, has one piece that's upward monotone, the other one is downward monotone, whereas the sentence with less is the opposite. So if all you do is you accumulate monotonicities, they're exactly the same.
Right.
So they're actually structured contradictions in the data that I didn't present this, but they're structured. You can actually read about it if you're interested. We have a paper in Sinn und Bedeutung from 2 years ago, I think. It was the conference from 2017 in Berlin, in Potsdam, and it was published in 2018. Look it up. You can find it on my website if you'd like, and you will see that. And it's kind of interesting to see that the same account that you would like to give to the double negation does not carry over to the comparatives.
Yeah.
Sorry, it was a little bit.
No, that was actually a great point, because I also thought about this issue when I first read your paper, that actually comparatives include a negation, right? But yeah, thanks so much. I really have to ask you this other question though, because that's the more neuroscientific question.
Maybe there's a student, but wait, maybe there's a student who wants to ask a question. Is there?
Sure.
Sorry for running your show. But
No. You're right.
Believe me, I'll answer your questions.
If there is a student who wants to ask a question now, please take the priority and I will shut up.
I would have a question, actually.
Yeah, please, go on.
Regarding the design of your study, because I just thought maybe it would
you put on your picture, I don't see you.
Oh yeah, I don't have it.
Wait, because it's, you know. Okay, go ahead, never mind.
While I'm working on my camera, well, that kind of, regarding the study, the design, did you ever thought about showing the sentence before you show the picture, or was it deliberately chosen that you always show the picture with the sentence? Or would it make a difference?
Great question. This was the homework assignment from last week to my seminar. It's exactly that. Again, so this left to right, like this precedence issue, arises in several contexts. It's a very good experimental point. Yes. So for instance, I'll give you a little bit of an intro. So like, if you go to, I think, Natural Language Semantics from 2009, you will see Martin Haeckel's experiment on most. And there, he gave them the sentence, and then they went through a bunch of screens, and they had to do something in each case. And he measured the time it took you to move from screen 1 to screen 2, and so on. There was a major issue of the order of presentation. In our case, we only get one measure at the end point of the sentence. Mm-hmm. So what you have to make sure, and in this respect, you're very right, that you know exactly what the subject has in his or her head when they're going through this thing. In the case of comparatives, I will get to your, I mean, the bottom line with your question is it doesn't make much of a difference in this particular case, but it's an important issue to think about, and you're absolutely right, because think about the comparatives. One thing that I said before is that in the case of these quasi-algebraic expressions, you can stop here.
Yeah.
And remember, we said that in comparatives, it's sufficient for you to read only the first half of the sentence, namely, there are more blue circles. Okay, you can stop there. Mm-hmm. So here is a possible explanation for why, despite the fact that with comparatives, you have mixed monotonicity, here is an explanation for why you got the reaction time effect nevertheless. The explanation says, because you stopped attending after you got the matrix. So you had, there are more blue circles, and that was sufficient for you, and you responded. There are fewer blue circles, that was sufficient for you, and you responded, and you did get the upward monotone and downward monotone pieces of the comparative, and this is the reason why you gave the same kind of performance. And am I clear so far? You just, you simply erased the part of the comparative that's giving you trouble. Mm-hmm. So for that, what we did, we actually ran this experiment twice. This is a part of that you will see in this Sinn und Bedeutung paper. What we did there is we thought exactly on what comes in first, and we forced our subjects to wait until they get the color of the circles in the comparative clause. And the way we did it is we had three possible color combinations. There was like yellow, red, and blue. And of course, in each of the images, only two colors featured. And we told our subjects, listen, you have three buttons to press: the true button, the false button, and the infelicitous button, the weird button. And we made sure that they understand it. And some of the sentences they got had a color term that did not appear in the image. So this was the weird sentences. And then this way we forced them to wait all the way to the end to make sure that they got the whole comparative, and that the effects that we get are not due to the first half of the comparative. And the comparative effect persisted. I'm telling you that in response to your question, not because it's answering your question, but because it addresses exactly the thing that concerns you, which I think is just the right thing, namely, do left-right directions matter in these experiments? Now, in this specific case, I think it doesn't really matter whether you present the image first and then the sentence, or you do it in the other way, as long as you know at every stage, you know exactly what the subject is supposed to be aware of. So for instance, in the case of these comparatives, well, I'm not sure actually. So anyway, so it's the kind of thing that can be answered not in a general way, but modulo the specific task that you have in mind. This is my only contribution here.
Okay, perfect. Thanks.
Thank you for the question, Victoria. Are there any other questions from students or non-students? Should I shoot mine? Can I? Am I allowed?
I'm here as a target. I'm here as a target.
No, I always have to ask permission to Hede before, you know.
Oh, Hede is the permission giver here.
He's my boss.
Listen.
Okay.
I'm just a foot soldier here.
So here's my question. So, you know, when we consider Broca's area, right, and also your enlightening works on Broca's area, there is a very nice correspondence between the kind of information that we get from lesional data, right, from patients that have a selective damage to Broca's area, and information that we get from activation studies, right? So we see, for instance, that, you know, we know very well that Broca's aphasic patients have agrammatism. Most of them show specific problem with syntax, with grammar, and also with specific kind of grammatical operations that you talked about in this work. So, like, for instance, movement and stuff like this. And also in the activation experiment, you're going to find that area to pop up. So my question with respect to the anterior insula is there any evidence coming from lesional studies that supports the idea that the anterior insula codes this kind of abstract semantic information or logical information, which is then particularly important for processing negation? Or do you have any idea about this?
Yeah, good. Okay, so I thought you were my friend, and now you're embarrassing me. But,
I told you.
No, good. That's good. Somebody has to set the record straight. Now, I'll tell you this. It's tricky. First of all, I want to tell you that not everyone believes that the picture that you presented is so elegant in the realm of Broca's aphasia. Okay. Not everyone believes it. I happen to be one who's been championing this position, and I believe it. And, you know, the evidence that I have so far seen has not changed my mind. In fact, I'm writing now a review of the work in functional imaging, because there's always somebody who would say, well, you know, there's an experiment that this confirms what you say, okay? But then you have to look at them carefully. So it seems to me that both in the kind of regular relationship between results in aphasia and results in functional neuroimaging is indeed there with respect to movement and perhaps a couple of other things. So I do agree with you about that, but you have to realize that not the whole world believes in that. I think I can argue my way quite compellingly about the validity of this generalization.
Yeah, I know that very well, by the way.
Yeah. Well, but
there is a lot of debate about this, but at least from the evidence is quite clear, right? Take a Broca's aphasic, and then there's going to be a very high chance that it has agrammatism, right?
It's always a question. I mean, it seems, see, the problem is this: you have no control over the lesions. I mean, this is some kind of experiments in nature, and you have no control over the kinds of experience that has affected the structuring of this person's functional systems, and you get what you get. So the answer to this kind of problem is to get quantities of patients, hoping that quantity would give you a payoff. Now, there's a set of papers by myself and the biomathematician named Dan Dre, D-R-A-I. You can find them on my website from about 15 years ago, where we grouped together lots of patients, because the problem is always to find patients. The numbers are fairly small. When you group them together, you represent them statistically in the right way, you find exactly the structure that you expect. And you can actually find it in these papers. What we are actually doing now, in an attempt to increase numbers, is we're catching these patients at the acute stage in the hospital. This is why we developed this app, this iPad app. It was an effort for 2 years. Andreas, it's mostly Andreas, Yantan, and myself. This is why we're doing it, because this will allow us to test many, many, many patients, and we test them on pretty much everything. They're still at the hospital. Without this kind of app, it's impossible, because the point is we don't have to be there to test them. You know, anyone can do this. These are sophisticated devices, and we don't have to be there for testing. But that's an aside. The evidence as it looks today is not wonderful, but it's a little bit indicative. If you give me a second, I might show you a slide. There's a paper that we have. There was a book that just recently came out, edited by Teresa Espinal and Viviane Desprez. It's called the Oxford Handbook of Negation. And we, the same group with Katrin Amunds and Jonathan Levinstein and these guys, we have a paper there together. And this paper looked at the comprehension of quantification, basically did this kind of experiment in Argentina. We had a very good group of collaborators there, headed by Virginia Haichenko, who's a local psycholinguist. And we tested 7 patients. Maybe I'll show you, if you bear with me for 1 second.
I'll be very happy.
I'll show it, well, I don't know, you're one of 30 or something.
I mean, anyone can go anytime, right? So we're not, we're not forcing people to stay.
Yes. Yeah, let me try to find, I'll show you this. I don't remember where I have it. 1 second, I'll find it. Maybe here. 1 second. No. Sorry about that.
No, no problem.
I think this is the PDF. No, but it's not my paper.
I mean, we can chat in private about this another day. I don't want to.
Yeah, of course, but
bother you about this. But
just
yeah,
sure. Give me one last try, and then we'll let everyone go. If I can't find it here, yeah. Okay, here it is. Right. I just want to show you one image, which is basically the same thing, and you'll see that the variability is just big, and you need big numbers to get something, but there's a little bit of hope. So we tested like 6 patients here, and you can see their performances.
Sorry, we are not seeing the. Oh, you're referring to the presentation. Otherwise, I guess you have to share the other documents. So
right. Sorry about that. You're absolutely right.
No worries.
Absolutely right. Here. Okay.
Yeah, nice. Thank you.
Okay. So here you have the performance of 6 patients. It's not very telling, namely what you see here, so that you see few, many, less than half, more than half. And one thing you can see here is that each patient sadly gives you a different pattern. What we tried to do is to actually recruit our computational force and try to correlate properties of their lesions with their performance. This is what you want. The numbers are ridiculous. In fact, the physicist in Jülich who does this for us, Peter Pieperhoff, was like, thought I was joking. It's just, these are not numbers. You can't be serious. The good news here is the following. If you look at it, with one exception, overall, the performance on the upward entailing quantifiers was higher. Now, notice I say higher, but it doesn't mean high. This is pathetic. This patient basically gave you garbage across the board, patient number 6.
Mm-hmm. So 0.5 would be chance, right?
Yes, 0.5 is chance here. So these patients give you, this patient gives you garbage. Mm-hmm. This patient gives you pretty much what you want. This patient doesn't quite give you what you want, but maybe, you know, I mean, the picture is disgusting. The good news here is that when you look at their performance on the non-linguistic stuff, look what you see. Where is it? So this is their performance on the inequalities. With the exception of patient 6 who gave you garbage across the board, and I don't know what, I think it was a she. I don't know what was wrong with her. Notice that everyone is giving you good performance on all these guys. It might actually be a little bit of another empirically driven response to both Hede and yours, and I think Victoria was the one who asked about it. Maybe I'm confusing something, whatever. But I mean, again, once again, it's a little bit similar to what I said to Hede early on, that the proof here is in the pudding. You know, and you can see that these 5 patients, they were, all of them were above chance, very clearly so. The number of items here is pretty big. I don't remember how many, but it's pretty big. And you know, in some instances, the experimenter who collaborated with us in Buenos Aires went back to the patients 2 or 3 times to make sure that they did it. And so I was present in a couple of these cases. I want to tell you one thing. These, well, never mind. So, but the thing is, so here you can see that the performance on these guys is very consistent with what we got in the other experiment, except what you get on the quantificational ones is very disappointing. And the hope, of course, is that once we have big numbers, we're going to make these things work. Mm-hmm. So the project that we have in the hospital in Jerusalem is in a stroke unit that gets about 1,300 stroke victims per year. We have an iPad there. In fact, we tested the patient yesterday. So we have an iPad there, and they test for us. They don't need to do much because the app is such that you get instructed from the app. You see videos of a person explaining to you what to do, and then you get the app and you basically interact with it yourself. The experimenter just has to be there to make sure that you're not falling asleep in the middle or something like that. And the hope is that we're going to get big numbers. In parallel, we get MRIs of all these subjects, and what we get is we actually scope them. I can show you if you want. Let me just change once again, and I'll show you what it looks like, what we get for each of them. It's quite a big operation. 1 second. I'll reshare my screen with you once this image comes in. 1 second, and then I'll let you go home. And that's it. Yeah, here. Okay, so now let me stop sharing, and then I will reshare, and you will see how we do this. Right. Okay. So here, you know, this is the neurologists in the hospital in Jerusalem, and you can see we get each lesion segmented 3-dimensionally. It's a joint project with the medical image processing at the Hebrew U. Also, we segment the lesions, and the hope is that, and you know, and then we get to compare these segmented lesions with the Eulish probabilistic maps, and we get specific measures for each of those cytoarchitectonic areas in terms of the degree of their impairment. And the hope is that we're going to find correlations, and that we're going to, that at one point we're going to include the insula. So if we have a couple of 100 patients, the noise will go, I mean, the signal to noise ratio will improve sufficiently. It's a big effort, but I think it's worth it to get both a healthy perspective and a pathological perspective on the same thing. And the same we hope to get also when we do these neurosurgical procedures. So the hope is that, and in fact it happened once with one patient, but you know, each patient is a big story, that when we stimulated cortex, we got a syntactic difference with respect to movement. We got a movement deficit. But when we stimulated subcortically, after parts of the cortex had been removed, we got a difference between Weniger and male, but not a syntactic difference. That was quite amazing, actually.
You're talking about the insula now, right?
Wow. Yes. Right. You know, so I mean, there are quite a few directions here. I wish I were a little younger, but because I have a research program for like another 20 years, I think. But anyway, if anybody would like to be helped with experiments, like Heather wants to do something with or students, or Danny, if you want to do something with monotonicity in German. I mean, German is like the best playground for this, for Dutch. So if you want to play, I'm game.
Yeah. I mean, is there any difference between Dutch and German? I mean, that could be the last question.
This you got your guy there to answer. It's not me.
Okay. Thanks a lot.
My pleasure.
Thanks a lot, and I will send you the link of your video, so then you can also share it with.
I can watch it before I go to sleep.
Yeah, it was really, 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 really amazing for me. So thanks so much, Joseph, and let's keep in touch.
Okay, bye bye.
Okay,
Thanks.
have a nice.
Bye bye.
Ciao.